For nearly 2,000 years, the Pantheon in Rome has stood practically unshaken. Its massive concrete dome, still the largest of its kind, has survived earthquakes, floods, looting, and centuries of decay. And get this, it's never been reinforced, never patched, yet it has stayed watertight. Now, compare that to a modern house in the U.S., built just 5 years ago, that already has a deep crack in the basement wall. Water seeps in every time it rains. How is that even possible? How can ancient Roman engineering still outdo us by centuries? Here's where it gets interesting. The answer starts with something simple, cheap, and widely available. A bag costs about $16. That's right, $16. And yet, this same chemical principle has been strengthening Roman underwater harbors for over 2,000 years. It can seal most common foundation cracks permanently. Meanwhile, many homeowners end up paying $5,000, $8,000, even $15,000 to repair damage that could be solved with this material. It's not expensive. It's not secret. Most people just don't know it exists, or they can't tell if a crack is minor, or if they actually need a structural engineer. This is exactly what we're here to cover. You'll learn the right materials, how to evaluate cracks properly, and when it's safe to fix things yourself versus calling in a pro. You'll walk away knowing precisely when to act, and how, to save money and prevent disaster. The story starts in the 2nd century BC. On the Gulf of Naples, Roman builders discovered something extraordinary. Mixing volcanic ash from Mount Vesuvius with burnt limestone and seawater, they created a mortar unlike anything else. This mortar could harden underwater, a property modern concrete struggles to achieve even today. And the science behind it? That's what makes it truly remarkable. Water didn't just leave it intact, it actually made it stronger. If you want to know why water sometimes strengthens old concrete, and how that knowledge can save you thousands today, stay tuned. And before we dive deeper, if you like this kind of practical history, subscribe and let us know in the comments if you've ever noticed a crack in your basement. Back in Roman times, builders didn't fully understand the chemistry. They relied on observation and experience. Fast forward to 2017. Researchers at the University of Utah finally uncovered part of the mystery. They found that when seawater seeped into Roman marine concrete, it triggered a chemical reaction forming tiny, interlocking crystals called aluminous tobermorite. These crystals grew inside the concrete, filling cracks and strengthening the structure from within. In other words, the sea wasn't eroding the concrete, it was helping it heal itself. Then, in 2023, MIT researchers, led by Professor Admir Mazik, made another breakthrough. For centuries, white lumps in Roman concrete were thought to be imperfections, but they weren't. These were reactive lumps of lime. When water penetrated cracks, the lime dissolved slightly and then recrystallized, sealing the damage naturally. The Romans had, essentially by accident, created a self-healing concrete almost 2,000 years before anyone truly understood how it worked. When the Roman Empire fell, this knowledge didn't vanish entirely, but it fragmented. Some regions continued to use hydraulic limestone, but the exact combinations and ratios for making structures last for centuries were largely lost. Castles, walls, and harbors built later often didn't hold up as well. They leaked or crumbled faster than necessary. It wasn't until the 18th century that this principle was rediscovered systematically. In 1756, British engineer John Smeaton was tasked with rebuilding the Eddystone Lighthouse near Plymouth. 2 earlier wooden lighthouses had already been destroyed by waves. Smeaton experimented with mixtures of limestone and clay and salt and fresh water until he found the right balance. The lighthouse, finished in 1759, lasted over 120 years. When it finally failed, it wasn't the concrete, it was the bedrock beneath it. This experiment laid the foundation for Portland cement, and eventually, the modern family of hydraulic cements we use today. So, the same chemistry that allowed a Roman harbor wall to survive centuries is in a $16 bag of powder at your local hardware store. Yet most people don't know it exists. Why? It's simple. Hydraulic cement isn't proprietary. Any manufacturer can make it. No single company can afford nationwide advertising campaigns, so it quietly sits next to grout and repair compounds, unnoticed. Meanwhile, proprietary foundation repair systems, branded, patented, certified, Charge high prices and advertise heavily. Visibility creates trust. Trust brings clients. And suddenly the expensive solution dominates consumer perception. But the truth is, for many cracks, that $16 bag works just as well, if you know what you're doing. Now, let's talk about what this means for your own home. Our approach isn't about replacing professionals entirely. It's about giving you the knowledge to make smart decisions. About 70 to 80% of foundation cracks are non-load bearing. These are often harmless and can be sealed yourself with just a few materials. The remaining 20 to 30%, they need a professional's eye and sometimes serious structural reinforcement. So how do you tell the difference? Start with the width. Hairline cracks, usually narrower than about 3 millimeters, are typically harmless. Next, look at the direction. Vertical cracks, or slightly diagonal ones running mostly up and down, usually don't compromise the structure. The house's weight is still being transferred properly through the foundation. To track changes over time, make a pencil mark across the crack and check back after a few months. If it hasn't widened or shifted, it's probably safe to patch with hydraulic cement. But some cracks are warning signs. Horizontal cracks in basement walls? That's almost always serious. Waterlogged soil pushing against the wall can be a major problem. Step-like cracks in block or brick walls. That often means one part of your house is settling faster than another. Cracks wider than 3 millimeters, or cracks that are wider at the top than the bottom, indicate movement in the foundation system. Pay attention to the rest of your house, too. Are floors suddenly sloping? Do doors stick when they used to close easily? Are gaps appearing between walls and ceilings? If you see these signs alongside foundation cracks, it's more than cosmetic, it's structural. Here's the technical bit. Hydraulic cement becomes extremely hard and rigid after it cures. That's perfect for small, stable cracks. But if the foundation continues to shift, a rigid repair will just crack again. In these cases, you need proper engineering solutions, carbon fiber bands, steel supports, or special piles. Never skip this inspection step. One small detail can mean the difference between a $16 DIY fix and a $5,000 call to a structural engineer. The key takeaway: many cracks are harmless and fixable, but understanding what you're looking at is critical. If you patch the wrong crack, you might just be hiding a deeper problem while it grows underneath your feet. Let's wrap this up. Foundation cracks can basically be divided into two groups: non-load bearing and load bearing. Non-load bearing cracks are usually the ones you can handle yourself. They happen naturally when concrete shrinks after pouring, expands and contracts with temperature, or when the house settles slightly. Start with a simple check. Width. Hairline cracks, under about 3 millimeters, are typically safe. Look at the direction, too. Vertical or slightly diagonal cracks are usually harmless. The house's weight is still being transferred correctly. Track them over time to be sure. A pencil mark across the crack is a simple, effective test. But some cracks demand your full attention. Horizontal cracks? Often serious. Pressure from waterlogged soil is pushing against the walls. Step-like cracks. Differential settlement is likely. Cracks wider than 3 millimeters, or that spread unevenly, signal movement. And don't forget the rest of the house. Sloping floors, sticking doors, gaps in walls or ceilings, they're all red flags. Here's why this matters. Hydraulic cement works wonders for minor, stable cracks. It's cheap, long-lasting, and accessible. But it's rigid. If the foundation keeps moving, that patch will crack again. That's when structural solutions, steel supports, carbon fiber bands, special piles are necessary. You can't skip this step. Missing it can cost thousands down the line. So, the real value isn't just the material. It's learning to read your foundation. Understanding when a crack is harmless and when it's a serious warning is what saves you money, headaches, and potential disaster. With this knowledge, a simple $16 bag can solve problems, while knowing your limits keeps you from making expensive mistakes. In the end, history, science, and modern DIY intersect here. Roman engineers discovered self-healing concrete centuries ago. Modern research explains why it works. And today, you can take advantage of that same principle in your own home. If you've made it this far, here's what to do next. Share this video with someone who owns a home. Comment if you've seen horizontal or vertical cracks. And remember, Understanding is the first step. A crack isn't always a disaster, but ignoring the signs can turn a small problem into a huge one. History, chemistry, and smart observation. It all comes together in your hands. And now, you know the secret that has been hiding in plain sight on a shelf at your local hardware store.